You know, like, do what you want to do, man. It's your class. What method would I use if the problem was this?
Use it.
Yeah, why?
There's a derivative and antiderivative right there.
Yeah, there's a function in there whose derivative is also in there. Yes?
Yeah.
What if I do this?
By
By
parts.
parts.
Where are my 180 students at? You don't have to raise yours. What did I say all the time? Before you do calculus, simplify. So before you do calculus to a function, you simplify. Can I simplify that out?
Yeah.
Yeah, how? Can I cancel a b? Hell no! Shit no! Right? It should all look at me like this.
1b squared times 1ab.
What can I do with that 2? I can take it down. And then it's basically double the first problem, so it's the same process as the first problem, because constants we don't really give a shit about. We should make sure they show up, but that doesn't change how we do a problem. Everybody with me so far? What if I do this? Is everybody cool with that? So that 2 can come down. It's basically the same problem as this. Woohoo! What if I do that? Can I still take the 2 down? Hell no, because that's not the property of logs. The log itself is being squared. But what method do I use? Why u sub? There's a function in there whose derivative is in there. You guys see that? So this is what I mean. All right, all of those are u sub, but I'm going to give you a problem. It could be u sub, it could be by part. In fact, what we're going to do today is finish up 7.3, go over 7.4. Tuesday is going to be basically the whole class almost is going to be, I'm going to have a handout. It's basically from 7.5, because 7.5 is all the methods all jumbled up. A big old freaking evil tossed salad of freaking calculus 2 things. Yes? And of course you know that's what the test is going to be like. I'm not going to say, now use by, no, I'm going to say integrate this shit. And you're like, okay. So, in every math class, the hardest step for a student is, when do I do this? I understand this process, Jeff, but when do I do it? Psh, just tell me when to do it. So on Tuesday, I'm going to give you something. You're going to work in groups. It could be any method. So part of understanding methods is being able to determine when you use them. Yes? Okay. So I always say to people, if I'm giving you a bunch of problems, and it could be anything, rule out u sub. Because at this point, we've got a few sections of chapter 7 under our belt. Do you all now really understand that if it's u sub, you kind of go, oh, thank the gods. It's just u sub. Do you guys see that? In Calc 1, you might have been like, oh shit, it's u sub, oh shit. Now it's, oh, thank the gods. It's just u sub, that's all it is. Okay. So, I think the last problem we didn't do, I have more of these. Where did I do with them? Here they are. Does anyone need this handout from last time? Shit. Why did I write on it multiple times? I have no idea. Who knows? Do I have more of these? I do. Does anyone need this handout? Okay. I should probably look up after I ask that question. Do it again. Anybody else? Oh, got one left. All right, so the one problem I think we didn't finish was down here. Okay, so let's kind of start fresh with this. I'm going to do this on another sheet of paper just because I want to. So very quickly, when you get this kind of problem, you just take a second and you say to yourself, would u sub work? No, because Because to make u equal the bottom, I would need 2x minus 4, and I don't have a minus constant on the top. There's no chance. It's got no shot. After today, one step would be, can I factor the bottom? You can't even factor the bottom of this, right? So what we did instead, because we're crazy, is we completed the square in the bottom. What did we get? We got x minus 2 squared plus 4, yes. dx. So I think the theme for this semester, and I apologize ahead of time, I'm apparently going to keep telling you you're in Calc 2. You're in Calc 2. When I see linear shit, I'm happy. I'm so happy. See that x minus 2? It acts the same as x. So if it was x squared plus 4 on the bottom. And so what's really funny about this problem, you might think maybe you could do u sub now, but it doesn't get that nice. But if it was x squared plus 4 on the bottom, if it was that, and I couldn't do u sub, I would do trig sub. X squared plus 4 is in the format of one of the identities for trigonometry, so then I think about trig sub. But instead of letting x equal trig, I'm going to let x minus 2 equal trig. And we have got to let go of x minus 2 being more than x. It isn't. It's just x shifted. It's the same shit. It's the same level as x. So I think the last time we got up to this point, what do I let x minus 2 equal? What trig function works in this form, in that template? No, secant would be minus, because secant squared theta minus 1 is tangent squared. 1 plus tangent squared theta is secant squared. So I really desperately want you guys on board with this. The biggest issue students have with trig sub is, when the shit do I let x equal which thing, Jeff? Dear God, do I just try them all and hope? No. This is in the form function squared plus number. Tangent squared theta plus 1 is one of the identities, therefore it must be tangent. You guys see that? If it was 4 minus x minus 2 squared, that would be in the form constant minus function squared. That's 1 minus sine squared. That's an identity. I would use sine. Do you guys get that? It's all about the form it's in. Maybe. Some of you guys will look at me like, can you please start making sense now? Why would I start now? So I'm going to let x minus 2 equal not just tangent. How many tangents? 2, because I need to match him, right? Or her, I can't tell. Biology and numbers gets really freaky. Okay, maybe. Or you can go further in the sociology of numbers. I don't know how they gender themselves. What do I do from here? No. What else do I need to figure out? So now I know, for example, do I know what x is now? Do I know what x is?
No.
Yes, I do. I know what x is. I'm sorry, guys. Not explicitly, but I know what x is. Right? What is x? 2 plus 2 tangent theta, yes?
Yeah.
What else do I need to know to kind of replace all the x shit in that interval? Dx. So if you want to, you don't really have to right now, but you can solve for x. I didn't really need to do that before I do this because that's a constant anyway. Who cares? Well, what's dx then? Kick ass. I can't stress enough. I don't blame you for this, but for students, you guys see that D stuff is just an afterthought, and you're like, if it's not there, who cares? It's got to be there. Trust me, especially if you're going to Calc 3. If you're going to Calc 3, you're going to be doubling double and triple integrals, and the order that those D shit show up completely changes how you do it, so they completely matter. So never leave off that little dude. How are we doing so far? Okay. Now I just rewrite my integral. Let's see. So I got 2 plus 2 tangent on the top. Can you guys see how the bottom, what happens with the bottom? If I plug 2 tangent theta in for this, that's 4 tangent, let me just write it, Jeff, just write it. 4 tangent squared theta plus 4, yes? And then dx we said was this business. you can already see something nice happening on the bottom, yes? Maybe? The whole reason we chose the trig. What happens on the bottom?
That's 4.
I can take out a
4
4 and then have tangent squared plus 1, which is
secant.
secant squared. So this is a really good example of one where I don't need a radical to show up in order for it to be trig sum. I just need the template of what a trig identity looks like with the squares, and I could use trig sum. Yes?
Sorry, do you mind just re-explaining like how you got from the just the step that you just did?
Oh.
Importing the data.
Alright, I'm sorry. Can you take a 4 out of these? Can you take a 4 out of the bottom? And what are you left with? If I take a 4 out of here, what am I left with? Tangent squared theta plus 1, yes. And what's tangent squared theta plus 1? Secant squared theta. Yeah. What's up?
No, I mean, this is clashing with my method, that's why. So
Oh.
don't worry about it. Keep going.
So then, what happens right there?
You can cancel.
Yeah, the secant squares cancel. I'll ask you in a minute how you did it. Because there are other ways to do this, but this
I mean,
is...
it's ultimately the same process, but don't worry about it. I'll get to it.
Chaboo! Chaboo! And then 2 over 4, all the 2's cancel, is that all right? If I distribute this, I get a bunch of 4's and they all cancel with this. So then I end up with 1 plus 1 tangent. You guys cool with that? You guys see that? You could pull a factor of 2 out with the other factor 2 in the top, makes a factor of 4 that cancels with the 4 in the bottom. Now what? Oh no! I can't. I don't want to do that because I changed the theta to make the integral doable. If I change back to x before I integrate, it doesn't make sense to do that because the whole problem was I couldn't handle the x shift. So when I integrate and then I'm going to bring x back. What's the integral of 1? D theta. Theta. What's the integral of tangent?
Negative.
Yeah, this is a good one to just memorize, to be honest. Tangent is sine over cosine. Now look, let me see if you guys can piece this together. Do you guys see how this would be natural log of cosine? Almost. Because this would be 1 over cosine times negative sine theta. So it's negative natural log of cosine theta. Is that okay? I don't know if you guys are with me or not. Do you guys need to see all the steps there? Okay. Let me just focus on this and then we'll come back to this. So if I just look at this. This is sine over cosine. If I let u equal cosine, what's du? Negative sine. So then I need a negative, so I put a negative and a negative, so overall I didn't do a damn thing. So then this becomes negative integral du and 1 over u, yes? And what's the integral of 1 over u? Natural log of u, and u was cosine theta. Plus e. But if I bring this negative 1 back up as a power, you could also write this as natural log. What's the inverse? I'm sorry. What's the reciprocal of cosine?
Secant.
Secant. You can either do this or you can do this. It's a good thing to know that the integral of tangent is natural log of secant. You could just have that in your back pocket, or you rewrite tangent as sine over cosine and do it on the fly. Yes? Either way, it's up to you. Yourself, anyway. You guys okay? So that was just that one piece. So if I come back, we now know, I'm going to write it like this just because that integral is natural log of secant. Yep. Now what do I do? Now I've got to bring it back to x. So if I come back up here, sec will just divide by 2 so I see what tangent is. Can I draw the triangle? Where's x minus 2? On the y side, and 2 is on the x side, and then this will be this because it'll be this, but it'll be the square root of it. if you guys are cool with that.
Mhm.
Just do it and you get it. I like that tagline. Just do it and you get it.
So the integral of 1 plus tangent theta, which is theta plus ln secant.
Yeah, so the integral of tangent,
Yeah.
this is just good to know. The integral of tangent is natural log of secant.
Mm.
And you can see that if you do u sub on sine over cosine. So if you don't want to memorize it, you could just always just do it on the fly. Like I said, it's very quick. But you know, if you want to, you just memorize it. Have one more integral definition. Yes? So now that I know all this business, well, first off, what's theta?
Tan of that.
Yeah, so this will be the arctangent of x minus 2 over 2. And what's secant?
Is 2 over that stuff.
Wait,
Well, no.
Can we just go back just a little bit on the?
Sure, yeah.
No, the other way around.
What's up?
I think it's
Where we at? What's up?
Okay, so I integrated 1 plus 1 tangent, and I got theta plus ln is secant theta.
Sure.
So we need to switch that back to x? Is that what we're
Yeah,
doing?
totally. So then I go back to where I define the relationship between x and theta.
Okay.
And if I divide by 2, I now know tangent theta is this.
Okay.
Tangent theta fundamentally is a ratio of sides of a right triangle, so then I can set up the sides and I can figure out the last side.
And my question is, how do we know that? Why is that the hypotenuse? I understand that.
Are you cool with this being x minus 2?
Yes.
And are you cool with that being 2?
Yes.
And are you cool with this being a right triangle?
Yes.
And are you cool with old Greek people? So then what old Greek person helps me get that last side?
Pythagoras.
Yeah.
I
So
see
square
that.
this plus this squared, x squared minus 4x plus 4 plus 4 is x squared minus 4x plus 8.
Okay.
Yeah, I'm sorry. I kind of skipped the work because I'm like, it's basically going to be the same shit because it came from that business, yes? But if you do it, you will get there.
Well, I was just watching the video lecture on Tuesday, and I was confused on how we were getting the
I got you. I'm sorry. Sometimes you just skip to it, and that's my fault. But if you just do the math, it actually comes out. You basically always get whatever was there in the original problem because it is what set things up in the first place. So of course it should show up. But you don't have to like remember that. You don't have to throw it in because you might throw it in the wrong place. Just set up the triangle and do old Greek. Yes. Okay. Is that all right? So I'm really sorry. I apologize. If I skip some steps, let me know. We're cool, but just let me know. You don't have to sit there and go, well, this is my life now. You just have this dude that's just gonna skip shit, and I'm gonna be like, I have no idea what's going on. No, say, how the hell did you do that? No, don't say it like that. Maybe give me a little grace, maybe, unless you're really pissed off. What the hell's wrong with you? Okay, is everybody with me? So it's a suggestion to memorize the integral of tangent if you want to. If you don't want to, part of my heart goes out to you. I love it because I don't want to memorize too much shit, but it's pretty good to know. Yes.
I didn't finish trying the bottom yet. Okay, thank you.
Okay. Now, so is everybody cool with that triangle?
Yes.
Yes.
Okay. And that just came from our first thing we wrote.
Mm-hmm.
What's the secant of theta?
Root that.
Yes, hypotenuse over x. Hypotenuse over x plus c. And then I just circle all that shit, thank the gods. I don't have to do more with that. I mean, I could break it up, but who wants to? I don't want to. Technically, the natural log of 2 could get folded into the c.
I was gonna say.
Who cares? Yeah. So, what did you do differently? What?
I mean, it's ultimately the same process. So what I do is I take what's it called? This part, right? And I always isolate the 1 every time. And then I do everything else. I do my tan, my arctan.
So you like factor out, you can factor out a 1/4 from the beginning. Is that what you're saying?
Pretty much here, right there.
Factor out a 1/4.
I
This
factor
is
out
on
a
your
quarter.
bottom, you can factor one. Okay, yeah,
Yeah.
cool. So whoever you are, I'm gonna call you IJ. He said he likes to make this a 1 always, which when you're doing trig sub, if that is a 1, then your choice of A is much easier. But then the trade-off is what you're letting equal that is going to be a ratio, but it works out. Yeah, yeah. So this is what I mean. I never did it that way because I kind of saw how to get the parts from what's there. I can't possibly show you every way to do something. I can't. I can explain a concept, and then you guys, like I said, you make it your own. You're like, actually, this makes more sense to me if I do this, and I keep getting the right answer. And then you can even show me, Jeff, I want to make sure I'm not just getting lucky, because that happens. Trust me, somebody did something in the homework, and then on the test question, the thing they did in homework only worked in specific cases. So the one I gave on the test book didn't follow that case, and it didn't work. So they were like, why the shit didn't it work here? And then we drilled down to what it was different. I don't know if you guys are with me or not. Calc 2. Oh yeah, we're in those. You've got to start making your own observations, your own tweaks to things, and then you can just run it by me. You can just say, Jeff, man, I do it this way. Would that always work? Am I assuming too much? And I'll tell you. And like I said, if I like the way you do things, I might steal it for myself. Okay. Yes. Oh.
How did you get from the integral of tangent theta to negative natural log?
Oh,
cosine
that was
theta?
over here. Rewrite tangent as sine over cosine. Do a u sub. Then you get here, that's the natural log. U is cosine. And then if I take this negative 1 power up here, 1 over cosine is secant. Yeah. So you can, again, just like with identities, you can either memorize a few and build the other ones, or you can memorize all of them. You can memorize tangent theta integral, or you can do it on the fly. Yes? It's totally up to you. It's your own choice. Okay. I feel like, let me see if I can say this to you guys. It used to be pre-calc when students started to realize, oh, there's play involved in math, and there's also my own way of looking at things will inform me how I'm going to do it. That has shifted to Calc 2, I think. Like, I see Calc 1, students see it as very mechanistic and I don't know how to say it. Mechanical. Yes? I'm thinking the mechanism fall out. It's very mechanical, whereas used to be it was more seen as conceptual, which is what it really is. You hit Calc 2 and you have to start looking at it more theoretically, a little more amorphous. I don't know if you guys are with me or not. You are now being forced to make the math your own, because it's got to jive with the way you look at things. I have no idea how you look at things. So I'm going to present it to you 1 or 2 or 3 different ways. And there's got to be at least 28 other ways to do it. Okay. So if you figure out a way to do it that seems to work, let me know. Show it to me, and I'll let you know if it's going to work all the time. Okay. Did we finish this? We finished it.
Yeah.
Okay. So listen, this example is one of the freakier examples you will see for trig sub. After today's lesson, if you see something like this, you're going to first try to factor the bottom, and if it's not factorable, then you go, oh shit, this might be a freaky trig sub. You guys with me? And of course, before all that, you go, will u sub work? And you're like, come on, u sub. So what if I did this? What if I added one thing in here? What if it was that problem? Does that change anything? What is it now?
U sub.
U sub, because if I let u equal this, then du is 2x minus 4, which is a multiple of this, and then therefore u sub will work. Always rule out u sub. Yes, sir. If the problem, so here. The way the problem is written, if I am u, the first thing I'm going to do is say, if I let u equal this, would u sub work? Well, you can see why it wouldn't, because this is a very key part to be missing. You with me? Oh, I'm sorry. I meant to write it as it was, and I wrote it as I wanted to make it eventually. Okay. If it was the way it is, I only have an x piece. I don't have this minus. I can't. There's no way it could work. If the problem had been this instead, so this trig sub, a little bit gross. We did it just now. This u sub. Fantastic, quick, beautiful. Do you guys see that? Once you see why one is one, the other is the other one, that's really the next level skill you have to have. First level skill is, can you do each process? Second level skill is, when do you do which? And there will be problems where multiple things work.
Mm-hmm.
But obviously, if it's between U sub and trig sub, okay.
So just to clarify, you're talking about dividing that by 2 and making it du over 2, so d is equal to
Totally.
minus 2?
Yeah, and not even that, to be honest. I'm really sorry. I'll try not to say this, but I just wish teachers would stop teaching solve for dx. It's driving me crazy. But why do I not have this in there currently? Because I have half of it. So if I just multiply the top by 2, but what makes that legal? Cut it in half at the same time. So I'm a big proponent because, I don't know, you guys, anybody's teacher tell you to solve for dx and just shove shit in? Okay, this is making me happy. Some of you guys are saying yes, and on behalf of them, I want to apologize to you. Because in the future of math, if you're taking a lot more math, or even just a little bit, it's a good skill to have to make what you need there, to kind of like balance what's there with what you need to be there. That's a skill in itself, and this is one of the first kind of places where you can see it make sense. The other way is just kind of blindly throwing shit in there and like, well, there's shit. You know, I'm sorry. Okay. But do you see that? Does that make sense? I need a factor of 2 on the top, and then it matches. So then at the same time, I just cut the whole thing in half. Overall, what did I just do? Overall, what did I just do? I multiplied the top by 2, and then divided the bottom by 2. What did I just do? I did nothing. I multiplied everything by 1, which is I did nothing. You guys with me? But I made the inside look different. That's the key, yes? Okay. So much of math is that. So much of math is just, you just did nothing. Way to go. But I reorganized. And now I'm able to do something else. Okay, I'll stop. Is that okay for now? Is that all right? Okay. So before I get into new stuff, is there any specific questions from like 7.1, 7.2, 7.3 before we get to 7.4? Or is there an example problem you want to do? Do you want to do another trig sub example? Or are we ready for something new? Or does anyone want to just go home? Too bad, we're not going to do that, sorry. Yes. I'm sorry. Sorry?
Can we do one more trick, sir?
Sure. Did you have a specific one? Or?
No, it's kind of part with what he's doing. Can you just break down the steps for doing the trig stuff? Like, just a little map of what to do.
So it's all about, if I see, let me see. If I saw this here, what's a good example of this? Well, I mean, like this. And again, I'm making this up on the fly, so this might be really disgusting, but we'll do it. I can rule out U sub really quickly, yes?
Yes.
And then the next thing you think is, would I want to do by parts? By parts would so desperately, not even just suck. One chunk of it is a radical with no x out. I can't integrate that by itself directly, right? And then I have 1 over x squared. Do you guys start to see what I'm saying? I do not want, even if by parts worked on this, I don't want to do it. But what tells me this has got to be, that trig sub would work? What tells me?
X minus
What exactly part of this?
the thing
X squared minus 9. Function squared minus constant squared, if I want to say that. So what trig does that match up with?
Secant squared.
Secant, because secant squared minus 1. Trig function squared minus constant squared. Function squared minus constant squared. They match. That tells me what kind of substitution to make. Because if I make that substitution, it flows right into a trig identity. And my hope is the resultant interval is easier, or in this case, possible. Yes? I don't know if this helps. So, what was the specific question again? I'm horrible. What's the idea of trig sub? Is that the kind of question? I already forgot who asked that, because I suck.
It was like breaking it down into
So this is a specific problem, but in general, step one is just, all right, step one is rule out u sub. In fact, I'm going to make that step 0. That is step negative 18 billion through 0 is rule out u sub. Yes? If you notice it's trig sub, then you look at the format of the squared part. Jeff, the letter S looks like that. Like there. That format tells you if it's x squared minus number, that's secant. If it's number minus x squared, that's sine. If it's x squared plus number or number plus x squared, that's tangent. Why is it those things? Because that's the form of the identity those things live in. Does everybody get that? You guys see that? No? It's okay if you don't. You just have to let me know. Yes?
Do you have those identities posted somewhere?
I have it on the handout that I gave you. Does anyone need this handout? I thought I asked that just a minute ago. I don't have any more left, so hopefully. Yes? Look. Form. Identity. A substitution. Related identity. Do you see the form in the identity? Constant minus function squared. Constant minus function squared. Function squared plus constant. Function squared plus constant. Blah, blah, blah. So you see how the form of the integral matches with the form of the identity. Cool. What's up? Yeah, that one, I don't know.
No, I'm going there right now.
All right.
Go ahead.
It's just a quick example I made, so who knows? It might not work out too
It
nice.
will.
Is that okay? Is that better? That's the whole idea of trig sub is we get to all right. Does anyone realize now that you might start thinking to yourself, are there other functions I could let x equal potentially? Hell yeah. There's a whole freaking field of study of different types of substitution. Trig sub is the tip of the iceberg. And it's the easiest one to teach because trig identities are very established. I don't know if you guys are with it. And it's also one of the more common substitutions to happen upon. But how many functions are there? So you could choose x to be natural log of u. That could be a valid substitution. Just like we picked x equals sine theta. That's a valid substitution sometimes, yes? I don't know if you guys, I need you guys with me. Why does this substitution work? Because it reformats the integral in terms of trig functions. And then I'm like, please let stuff cancel and become something I can do. Maybe. So the minute you learn u sub, that really just opened everything up because now I could, as long as I could replace everything with x with the new variable I'm subbing, I'm golden. Am I guaranteed the result will be possible or easier? No. But I'm hoping if I make a substitution, I'm hoping what it ends up looking like is easier or doable. Period. So for example, we already did this problem here, but the radical is a big giveaway, but that's not required. It's in the form number minus or plus function squared, yes, so
Did you just say it's not required?
the radical is not required. In fact, in that last problem we just did, is there a radical in it? No. So that's why I want to kind of figure out how to redo this. 90-something% of the time it's going to be a radical. If you did any homework in 7.3, you agree.
Yep.
But it doesn't have to be there. It just has to be writable. Is that a word? Who knows? In this form, in the interior form. Most of the time it's going to have a radical. That's just what happens. That's what happens based on observations. It's just not just what happens what math people make, it's just what we see. Relationships end up having these radicals in them. That happens a lot. But not every time. I just need a squared minus x squared, or x squared plus a squared, a form like that, because then that's the form of the trig identity. Okay. Anything else on that?
So the inside is the most important thing.
The chunk that's 16 plus x squared, or 3x squared minus 11. Now, real quick. 3x squared minus 11. Those numbers suck. I need you to be with me. Was this one relatively easy? Because I make x equal to 2 sine theta. Okay, what about, what did I just say? I forgot. 11 minus 3x squared.
Factor 11.
Can I use u sub? Can I use u sub? No. So then what do I have to use? Trig sub. I've got to use trig sub. How do you feel about the numbers?
It's fine.
Huh?
It's fine.
Good, I'm with you. How's everybody else feel? Are they the numbers you would like to see?
No.
No. But watch, one thing you could do, and this is where maybe you and I agree, I could factor a rad 3 out to make the coefficient of this 1. Let's see if you guys are cool with that. Do you guys know we're in Calc 2? So, 11/3 shouldn't bother us. If that was if that was a 4 minus x squared, I would let x equal 2 sine theta, right? Like we did?
Yeah.
Where did 2 come from? Square root of 4.
Yeah.
So what do I let x equal here? What do I let x equal here?
Sorry.
Square root of 11/3 sine theta. When I square it, that becomes 11/3, which allows me to factor that shit out and uncover my identity. Does that make sense? Hopefully you guys picked up on that. That's why we let a be the number I put in front of the trig. I want to be able to factor that out, so I uncover the identity. Does it have to be a perfect square then? No, I'm just square rooting the damn thing. So that when I square it, they become the same. I can take that shit out. Perfect world, I get squared numbers. Do we live in a perfect world? Every day I see evidence we don't. Damn it. It's pretty good. Could be better. We'll get there again. Okay. I don't know if I'm helping. I hope I'm helping. Okay. Listen, on a test or a quiz, or on a test, quizzes are very bare bones. Tests, I do give a few problems that will push you a bit, but I also mix in basic problems, just straight up problems, right? So I will have problems with like 9, and I might have a problem with 8/5. Numbers don't freak us out. We can't let numbers freak us out. They're just numbers. If I see a number that's ugly, I'm like, thank God it's just a number that's ugly. Numbers don't matter. Okay. Now the number's going to come kill me in my sleep. We don't matter? Okay. I'm sorry. I got a little too general on that. Is there any specific questions somebody has? Or I'm really sorry. I didn't finish my list of steps, but I don't know what else to say. Format of the squared part tells you what trig sub to use. The minute you identify x equals blah, blah, blah theta, you do dx, you make substitution, then it's all just brute force. You take the derivative, you substitute the shit in, you see what cancels. The whole time you're doing this, like, come on, more shit cancel, come on. Yes? And then you take stock at the end, when all the dust settles, you're like, now what do I do? And there is no step 3. It's just based on what it looks like after that. I don't know. It could look like anything. It could look like anything. I don't know. And I'm really sorry if that doesn't make you feel good. I'm sorry. It's just the reality. You just treat it as if that's the problem you were given. And you say, how do I do this problem now? Okay, maybe. I told students in the past to take a piece of paper and cover the work they did before where they are now. Treat it like it's a new problem. Don't have all the other shit in your head, because who cares about that shit? You're here now. Yes?
Can we finish that problem we started, just so I see if I'm doing this right?
Oh, which one is it? The one I made up out of
The one
nowhere?
you made up.
Oh boy. This one?
Yeah,
Okay, let's see how far this goes.
I just wanna see if I did it right.
Okay.
It's not that bad.
No, thank God. And real quick, just to let you guys know, if I just make one of these up out of nowhere, it is entirely possible that it ends up very disgusting. I don't think impossible quite, but it could end up being very disgusting. So it sounds like this is not too bad. Okay. So what trig sub am I going to use? This is a nice clean example problem. It's got a nice square number. Yes, I want 3 secants. So that after what's the derivative, by the way?
Secant tangent. D theta.
And if you wanted to, you could even just right now just put what x squared is for yourself, right? You don't have to. And then when you sub all that business in, we'll get 9 secant squared theta minus 9 over 9 secant squared theta, and then dx is 3 secant theta tangent theta d theta. Oh my god. You start to see where it won't be too much more for me to make you turn your paper like this. You turn your paper like this sometimes to do some problems. So the first step was I rule out u sub, identify which trig identity is applicable, make the substitutions. Now I am on the kill step. Kill, right? Or cancel if you don't like killing, I'm sorry. My math is very violent. Does anything, well, first off, what can I do with the whole reason we did it this way, this thing?
3 tangent.
Yeah. Square root of 9 comes out, that's 3. Secant squared theta minus 1 is tangent. Square root is tangent. And then I can just start.
Okay,
What's up, sorry? Is that okay? Just doing one thing at a time. So that becomes this.
how did that, I'm sorry, can you show how that became that? How does
What comes out? Okay.
How does secant squared turn into the square root of secant squared is tangent?
You ready? What comes out? What comes out? 9. What am I left with?
Okay, so identity.
Minus 1. Blah, 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 blah. I'm just going to focus on the top, yeah? What's the square root of 9? 3. What's secant squared theta minus 1? Become an a and an n. Blah, 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 blah. And what's the square root of tangent squared? Tangent. Cool. So if you do enough of these, you start to feel the pattern. You kind of jump up, 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 up. But yeah, please, dear God, I'm really sorry. This is an example. If I skip steps and you have no idea how I got there, just say, hey, man, could you like show me the math, Mr. Math Teacher? And I'm like, oh yeah, I guess I could. There's going to be any explanations in this class, Jeff? Yeah. Now what?
Cancel.
Yes. So 3 times 3 gangs up and kills him. 1 secant dies.
Tangent squared.
If I bring the secant theta up, it becomes
Cosine.
times tangent is sine. So I get like sine theta, tangent theta. Now, that's not necessarily what you want to see there. But let's see if we can kind of break this down. Real quick, sine and cosine go together beautiful, yes. Then, I'm sorry, go ahead. Again, here I am skipping steps.
No,
Sorry, yes.
just sine. Because I got cosine.
Tangent sine over cosine. If you bring this up, it becomes cosine. These kill each other, so that's the sine.
Okay.
And then that tangent's there, yes?
Yes.
Okay. If it was sine cosine, that would kick ass, because that would just be a u sub, or even a double identity if you want to, double angle identity. Let me stop for a minute. Yes?
I get the cosine part, like where it comes up, but I didn't get the sine part.
Because that's on top of tangent. Tangent sine over cosine, the secant comes up, kills the cosine, left with the sine, okay. And then the other tangent's just been hanging out, watching all the bloody killings. Okay. So now I pretend as if that's the problem I gave you. Because that's all that matters. That's where we are now, right? Later I gotta remember what my substitutions were. Right now I can pretend like that's the problem somebody gave me. What do I do? Does u sub work directly the way this is written? No. Is there a way to rewrite this so things work better together?
Yes.
How can I rewrite it?
In terms of sine over cosine.
Yeah, tangent sine over cosine times sine is sine squared over cosine. Do it again.
rewrite sine squared.
Yes, okay, good. Rewrite sine squared so it works better with this guy.
Secant.
So it'll be secant theta minus cosine theta. Now, this is the part that gets interesting. Yeah, it's neat. Let's talk about that by itself, because I think it shows up in at least one homework problem.
Multiple.
Oh, okay, thank you.
It is.
Let's talk about this, because this is one of the coolest things that happens in mathematics. It's happened to you guys already. Let's take a look. Let me stop for a minute. I'm really sorry. Everything makes sense there. Tangent sine over cosine, sine times sine is sine squared. I rewrite sine squared as 1 minus cosine squared, which makes sense because there's a cosine I could cancel, right? 1 over cosine is secant. Cosine dies. Everybody sheds a tear for the little quote. I'm going to focus on this integral because this integral is easy. How do I integrate secant theta, Jeff? So let me ask you this question. What is the derivative of secant theta plus tangent theta? What's the derivative? Secant theta, tangent theta, plus secant squared theta. Now, can I take something out of this? Can I factor this? And by the way, I don't blame you if you're like, where the shit did that come from? You should be that way. Don't worry about it. This is just me doing some side work to explain what the hell we do. Can I take a secant out?
Yeah.
What am I left with? So do you see something weird? The derivative of this is secant times it. Isn't that neat? And you're all like, very good thing to do now is, and, Jeff? So watch this. This is so cool. Okay, good. So some of you guys have maybe run across, I think they do this in the book somewhere. I can't remember. This is a time, and you should have seen this in Calc 1, if your teacher proved to you a product rule. If they proved it to you, you should have seen this idea of one way to look at this is I can add something and subtract the same thing. So overall I did nothing. Or I can multiply top and bottom by the same thing, so overall I did nothing. So watch this. Don't I have a factor of secant there? Isn't there like a secant times? So if I multiply top and bottom of secant over 1, if I multiply top and bottom by this, now I need some of you guys to realize what I'm doing right now is nothing that we would expect you to do by yourself. There's no real, I mean, it's possible, don't get me wrong, because humans didn't know this shit and then we did it. So somebody somewhere was playing, I don't know who to give the credit to for this.
Seriously, dude, that's incredible.
Somebody was just sitting there, well, of course, what did they have to do? Did they have Xbox? Did they have YouTubes? Did they have cable TV? No, so what did they do? They got out the little parchment paper and the thing, and like, let me play with math. Woo-hoo-hoo. Okay. Right? You with me? So in all the 30 whatever years they got to live, they just played with math and came up with shit. On the top, I get this. I am writing exceptionally well today. Do you guys see what it is now? It's u sub. Yes? Isn't the top the derivative of the bottom? Again, no way in hell I could legitimately expect anybody in here to just know to do that. Is it possible you could, if you played around with it? Of course, you could possibly come up with this, just playing around with it. You with me? But I want you to realize right now, if you're sitting there going, how the hell would I know to do this? I'm telling you directly, I'm not expecting you to. This is one of those trippy little things. So if I do a u sub, if u equals this, du equals that. Is that cool? I don't want to write too much. So this will be integral of 1 over u du, which is natural log of u, and u was this. So what is the integral? Let me just kind of collect all this shit together. What's the integral of secant? It's this. I should expect it to be gross, because freaking secant is 1 over cosine. And what's the integral of 1 over cosine? It's not u sub, because they don't have a sign in there, damn it. So I should expect the answer to be potentially gross. or not immediately obvious because it's a freaky ass thing to try to integrate. Maybe. It's so cool to see that though, because this happens so often in math. In fact, you get high enough in math. I remember I had a piece of paper that had 1 equals blah, 1 equals blah. There's a billion different ways to write 1. So there's so many situations where you're like, oh, if I multiply by 1, which is blah over blah, this becomes something I can do. So I wanted a whole bunch of things that were equal to 1. So then I can use them wherever I needed to. Do you have to do that right now? No. What class was that, Jeff? I don't remember, man. I'm 53. Shut up. I don't know. It's a long time ago. But I remember this piece of paper. It's probably somewhere in my house. I don't know. Okay. I don't know if you guys are with me. I'm really sorry. I do tend to go on this general idea of stuff. We can always come down to specific details. Yes? So this is a detail that we know now. The integral secant is this. On a test or something, if I know that's going to show up, I would give this to you. Because I'm not going to make you memorize it. I'm not going to make you derive it. Yes? Okay. All right. So the steps of trig sub are rule out u sub, notice it's trig sub, use the correct substitution, simplify, reevaluate. There's the steps. If it's not detailed enough, too bad. That's the way it is. A reevaluate step at the end, that's everything. Could be anything. Makes me feel better, Jeff. I'm sorry. It's the way it is. Okay. So what I want to focus on, holy shit, for the rest of it. This is fine. This is kind of beautiful. We have time. We have time. 7.5 is just all of the trig methods. So 7.5 is nothing new. And then we only have a few other sections after that. Nothing too big. Okay. So what I want to talk about today is one of my favorite things. And we used to teach this in pre-calculus, and we sort of stopped doing that. When we weren't allowed to teach algebra anymore, we're like, we have to teach algebra to pre-calc, so let's eliminate some stuff. This is let me do this with you. Can you guys take a second and add these two things for me? If anyone says 2 over 2x minus 3, I'm going to leave. Good luck. Should be pretty quick, right? Fractions are awesome. I always equate it to being a parent. You have 2 kids, they have 2 bowls of ice cream, and one has sprinkles and the other one doesn't. So you want to give each one what the other one has that it's missing, right? Okay. So what's the first dude missing the other guy has? That's insane. And very quickly, just to help, do either one of these have an X on the bottom? Do either one of them have an X? Nope, neither one has an X. Neither one. And this is where I would hope somebody would come up and go, Jeff, what's that, man? So, real quick, help me out. Does this have a 5 in it? The bottom, does it have a 5 in it? Does it have a 5 in it?
Yes.
Why? Because it's 5 times 6. Does that have a 5 in it? Isn't 11 5 plus 6? Isn't 11 5 plus 6? Okay, all right. I just got to do this very quickly because we don't really do a lot, as much with this as we used to. So I got to be I have to be aware that not all of us are like immediately looking at this correctly. Neither one of these has an X. So I can't just give him like a -7 and then they're the same. Do you guys see that? Because I can't subtract something from the top and bottom. It makes no sense. So he's got an X plus 2, he's got an X minus 5. Give him an X minus 5. Give him an X plus 2. And what do you get? X and X is 2X. Negative 5 plus 2 is, Jeff, you can do it. Negative 3. Okay. Which is fat. It's amazing. And then if I wanted to, And you're all like, hey Jeff, remember when you said this is Calc 2? Why are we doing this shit? Because just for this specific problem, is everybody cool with that? Everybody cool with that?
Yeah.
So that result came from the addition of two separate fractions where each one had a factor of the end result on the bottom. So what if we didn't know any of this, and I said, I want you to factor this, I want you to do this problem. Oh, of course it just happens. Oh, fuck yeah. Okay, the likelihood that that would happen. Do you guys see why wouldn't you sub work on this?
Yes.
Okay. God damn it. The probability of that happening was really low. All right, just deal with me for a second. I'm sorry. I'm going to make this so not happen. Okay. Here, make this a 4. I'm just going to do this very quickly, okay? I'm going to multiply this by x plus 2. I'm going to multiply him by 2x minus 5. And at the bottom, I'm going to get 2x squared minus x minus 10. So on the top, I get 9x minus 18, I believe. Okay, now, dear God. Maybe check me. Let me see. 8, 9, negative 20, negative 18. Okay, good. I'm really sorry. Just give me a second. That was crazy. That was basically like picking the right lottery numbers for, like I picked 3, maybe. And real quick, I'm really sorry. Does anybody notice the problem I just did? U sub would work. If I wanted to integrate this dude, we don't know this, and this is the problem. Will U sub work? The derivative of this is 4x minus 1. Yes? Which I can't make match with this. Now, real quick. There are kind of nifty ways to kind of make certain things show up. I'm not going to go there yet. But you guys see how U sub will not directly work. Okay. If I knew that this was this. Yes? If I knew that this was this, I can rewrite this integral this way. Yes? Now, real quick, let's do this part first. We'll leave this in a second. What is the integral of 4 over x plus 2? Does anyone know? You all know. Don't worry about the 4, right? It's just a multiplier. What's 1 over x plus 2? The integral. Where would that come from? Whose derivative is 1 over x plus 2? Natural log out of x plus 2. Yes?
Yes.
And I just put a 4 in front of it because there's a multiple of 4 there. Is that cool?
Yes.
So again, constants cannot trip us up. They do what we want them to, damn it. It's the functional parts that screw us over. Absolute values. Everybody cool with why we put absolute value in natural logs? So I have to match the domains. Okay. The only thing I have to be careful about here is this is this, except of course what? Yes, because a 2 would come out of a derivative. I've got to kill the 2 that would come out. It's 1/2. So when the inside is linear, it's easy. So, okay. This is the point of this exercise, is we know how to put these together. We have to come up with a process. If I can come up with a process where I can tear this back apart, then the integral becomes much easier. Yes? I see some faces out there that just realize where we're going, maybe have seen this before, and they seem to maybe not be too excited about it. I'm sorry. All right. So hopefully I can make this make more sense if you've ever seen what we're about to do. And very quickly, one thing I have to say, and you're like, you have to say a lot, dude. You won't shut up. I'm sorry. Dear God, dearly beloved, dear God, is this right? Is that correct? Please stop.
It's hard to.
No, it only works directly if this is linear. The minute this is more, the derivative would be more involved. Hence, the integral is more involved squared. I mean, integrals are always going to be worse than the associated derivative would be. So, once everybody learns the integral of 1 over x is natural log of it, everything becomes natural log. I'm like, no. Is everybody, you guys kind of with me? Just because it's on the bottom doesn't mean it becomes natural. What would make this become a natural log answer? Does anyone know? If I put an X up there, then U sub would work, and then it would be a natural log answer, yes? Because what is this missing? If this was what it's supposed to be, it's missing the chain rule piece. So if there was an X there, then okay, is everybody with me?
Yes.
Okay. So what we're going to work on developing, probably from today to the beginning of next time, is a process that when I give us a rational expression, right, polynomial over a polynomial, if I can factor the bottom at least somewhat, maybe I can rip it apart into its parts. I can undo putting fractions together. Yes? And it's sort of like when I teach logarithms, very often I get students who just come in, they hate logs. And then once I show them logs are just powers, what power does this need to become this? They're like, holy shit. So it's just a reformulation of what the thing you're doing means. So if you've seen this before, just give me a shot, okay? I'm going to take my shot. A real shot would be enough. No, let's go here. So very quickly, if I had something like this, can I factor the bottom? Yes, x plus 2, x plus 1. So therefore, it must have come from something over x plus 2 plus something over x plus 1. So this is such a cool step. Anybody have to take DiffEq eventually? Differential equations are. That's the affectionate little nickname. What we're about to do, and in fact, if you're not going to, you still have to be able to do this. But the process we're about to start is very similar to what we do in classes like differential equations. We assume what the answer looks like, and then we get the details. Because the assumption we're making is founded. It's gotta be. Do you all agree with me that since this, the form this is in, and because I can factor the bottom, let me write this over here. This must have come from something over x plus 2 plus something over x plus 1. In fact, we have, now blank spaces are no good in math. So I'm going to call, the thing we chose to use here is capital letters alphabetically. And maybe. Do you guys see the idea? It had to have come from something over x plus 2 plus something over x plus 1. Okay. Really, this step is everything. This step right here is everything. Now I've got an equation, and the equation I know is true. Because it has to be true. That's where it must have come from. Therefore, I can do shit to both sides. You can only do something to both sides of an equation if you know the equality is true. So what's immediately the thing I want to do to make this equation look better? Well, multiply by the LCD.
Yes.
You guys with me? Then everything's going to be so much better. I mean, this equation is gross because look at all the fractions. Yes? So let's kill them. There's enough fractions where let's kill these guys. Don't kill me. I have so much to live. Shut up. You're dead. Okay. Sorry. This is legal for me to do because the equation is true. So I can do stuff to both sides. Die. Here, effectively, the A picks up the thing it didn't already have. That's a shortcut.
Yep.
So I don't have to write as much shit. Whatever it has is picking up the other stuff. So this is going to effectively pick up the x plus 2. Now, I'm going to show you the long-ass way to do this, and then I'm going to show you the shortcut. The reason I want to start the long-ass way first is because the shortcut obviously doesn't always work. That's why it's a shortcut, because it doesn't always work. Let me stop for a minute. Is everybody still with me? Everything we're doing right now came from the fact I could factor the bottom, and therefore I know the assumption that it came from something over one piece plus something other piece has to be true. So that equation is true, I can do shit. Now, there's a very cool, one big reason I don't want to start with a shortcut, like I said, is it doesn't always work. But also, the method we use is used in other places. It's called the method of undetermined coefficients. And it's so kick-ass. I love the shortcut to death. I love it. It doesn't always work. And actually, I have a big place in my heart for this. And you're like, I'm probably going to hate it then, Jeff. And I'm like, I'm sorry. This says x plus 4 equals ax plus a plus bx plus 2b, yes?
Yes.
By the way, if you've seen this before and you know the shortcut, great. Sit there for a minute. This is x plus 4 equals a plus b x. Is that cool?
Yes.
Plus a plus 2b. What must a plus b be if this equation is true and we know it's true?
1.
Do you guys see that? A plus b has to be 1. Because if that side becomes that side, and we know it does, because the equation's true, whatever the shit a and b are, they better add to be 1, yes?
Yes.
Do you guys see that?
Yes.
That kicks so much ass. Okay. Do you see why it's called the method of undetermined coefficient? We're going to relate the coefficients on both sides. What must a plus 2b be? A plus 2b be? A plus 2bb must be 4. Now you can imagine more complicated equations getting more letters, A, B, C, D, E, F, G, and then you want to do this less, yes? The bigger the system of equation gets, the worse it is. Some of you guys know how to use matrices to do that, blah, 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 blah. But the shortcut's kind of nice. Is everybody with me so far? Yes, sir.
Can you explain why a plus b is 1 and a plus 2b is
Real quick, do you agree with me that this, we know the equation is true? Okay, if we know the equation is true, then this has to become this. This, why is the equation 5 plus 2 equal to 7 true? Because 5 plus 2 becomes 7. Yes? And you're like, thanks, Jeff. So this has to become this. That's what the equation means. So what does a plus b have to be to make it become what it's supposed to be? A plus b has to be 1. Equate the coefficients. What does the constant on this side have to be? It has to equal 4, the constant on that side. If I had x squared terms, I could take their coefficients and equate them. Yes?
How do you know how to like which part of like the equation on the right side to break up, right? Because you have 2 different plus signs, so it could be like.
Oh, no. I got all my x shit together,
Yeah.
and I got all my other shit together. That's what told me.
Okay.
What are my like terms? Ax plus bx. So how many x's do I have? A plus b of them. And what are my constants? A plus 2b. So I have a plus 2b.
Okay.
Yeah. And what does a plus b have to be? 1. How do I solve this system of equations? Does anyone remember? Yeah, if I just change the signs, I can add these and I can kill the a's. Remember, it's elimination? Okay. So 2b minus b is 4 minus 1 is, that's crazy. A plus b is 1. I know b is 3 now, so what's a? A plus b is 1, yes?
Yes. So
negative 2.
negative 2. Yes.
And by the way, how much have we looked at this? Not much. So it's going to get more complicated, obviously. But this is basically how they all work. So what did we just figure out? And you're all like, I don't know. We figured out, where'd it go, Jeff? There it is. We started with this, yes? And we knew that that looked like this. Did we figure out what A and B are now? What did we say A was?
Negative 2.
Negative 2. And what did we say B was?
3.
3. Let's check it. Let's check. You're like, okay, math boy. Show me that works. How do I check myself? You don't check yourself. How would I check myself here? What's supposed to happen? If I add these, it's supposed to be this. Yes? So I give this guy what he's missing. I give this guy what he's missing. And then it's all over the two together. Negative 2x plus 3x is x. Negative 2 plus 6 is 4. Would you look at that shit? And if I multiply the bottom, holy shit. Of course it is. Of course it is. To me, the step students have the most trouble, there's two of them, is the first step, just assuming what it looks like. But of course we can assume what we know it came from this. There's no question. And the second step is the one that I don't blame you for having trouble with. I'm surprised only one person asked me about it is, how the shit did you know what a plus b was? And that's just equating coefficients. I said method of undetermined coefficient. That's actually from differential equations. But equating coefficients, that's what we call this. Just equate all the terms in front of x have to equal what's in front of x. The constants have to equal the constants. The terms in front of x squared have to equal what's in front of x squared. That's the only way this equation can be true. This is trippy as shit. You've probably never seen something like this before if you've never done any Calc 2 before. Did anybody learn this in pre-calc? Does anyone learn this before? Okay, a few of you. Oh, several of you. Kick ass. Did I just make it more confusing? I'm sorry. You're like, my teacher showed me an easier way. I'm like, I suck.
You showed both.
What's up?
The long way and the shortcut.
I am going to show you the shortcut now. So let's come back. I'm going to show you the shortcut.
Bless you. Bless you.
The shortcut does not always work, but I can almost always use the shortcut at least once or twice to help me. Okay, so I'm going to come back to this step here. The shortcut on this one is almost silly because it's just so quick anyway, but in this equation, what could x be? Anything. Do you see a value for x? And what am I trying to get? Am I trying to solve for x?
No.
So this is one level of differentness. Yes, just to make a new word. I love English. I don't care about x. I care about a and b. What sucks is that there's two things I don't know. There's a and there's b. Damn it! The number of things I don't know is too damn high, which is generally true for me, for most students. Can I pick a value of x? Because you just told me x could be whatever the shit I want it to be, correct? Could I put 11 in there for x? Would it do much for me?
No.
It wouldn't do shit for me. It would be terrible. What's a really good value of x to use that would end up killing one of the dumb things I don't know?
Negative 1.
Negative 1. So let's try it. You guys see that? We have control here. Who are we? Humans! We made this shit. So I'm going to let x be 1. I'm sorry, negative 1. And then what happens? What happens this side? If x is negative 1?
3.
Holy shit. If x is negative 1?
0.
Die. If x is negative 1?
1b.
Is that what b was?
Yeah.
What? What else can I let x equal?
Negative
Put it down here, Jeff. Negative 2. Negative 2 plus 4 is 2. Negative 2 plus 1 is?
Negative 8.
And negative 2 plus 2 is 0, so then I get a is negative 2. Is that what we got?
Yeah.
Hell yeah. So, that's so freaking cool. It's because x could be anything I want it to be, and I'm not trying to solve for x. Therefore, I can let x be the thing that kills some of the unknowns. If I have an equation with a bunch of unknowns, I want to kill some of them. If I had one unknown, that kicks ass. If I have 5 unknowns, no. When am I not going to be able to do the shortcut? If this was, well, okay, I want to say this two different ways. If that was x squared plus 1, x squared plus 1, is there a real value of x that makes it 0? To be really true, you could use complex numbers. Do you want to?
No.
In that case, I would default to the matrix approach, or the systems of equations. You with me? But what happens most of the time is I might get like an x squared plus 1 here, but I might get like an x plus 2 there, and then I could use the shortcut a little bit. I can kill some letters. I can make things look a little better. Do you guys follow? So what happens most of the time is the shortcut works to a certain point, and then you have to let the system of equations take over. Okay, I like it. Now again, we have just barely started talking about this. I already gave you the handout. Who knows where I put it by this time? It's on the other side of the trig sub stuff. Here we go. You can have that, or maybe I'll take it. The first example is pretty much exactly like what we just did, yes? And I show you the textbook method and the alternate method, the picking a value of x, yes? But then, now next time we'll get into this, what happens if I have repeated factors on the bottom? Like this has an ax plus b twice, yes? Why does it look the way it does? What happens if I have an irreducible quadratic, meaning it's something I can't factor? Why does it look the way it does, Jeff? Okay. So like I told you, it can get worse. And look at the last example, A, B, C, D, E. Yes? And then you're like, please let me pick some values of x to kill some of those. That's too many freaking unknowns. So I just barely laid the groundwork. Yes? So I'm going to adjust my plans for Tuesday a little bit. Probably the first half of Tuesday is going to be explaining the other things, doing some more examples. And then the other half is going to be working on a handout that kind of reviews all the forms of iteration. Okay. All right, guys. If you have any questions, let me know. Otherwise, I'll see y'all next week. If you have any Monday classes, your Monday's a holiday. If you didn't know. So don't come to class. You'll be very lonely.